how to present. Presentation is most important during writing your exams. So now I will start with the 11 members. Column chromatography. Let's move on to the second part. We will start the class. Next part is column chromatography. In column chromatography, according to classification, what are the chromatographic techniques we have discussed? HPLC, GLC, and column adsorption chromatography. Before moving on to the techniques under column chromatography, we have to see some basic principles behind column chromatography. In that, firstly, history about column chromatography. It was developed in 1903 by Russian botanist Michael Sweat. He produced a colorful separation of plant pigments through a column of calcium carbonate. He used adsorbent as stationary phase as calcium carbonate. Column filled with calcium carbonate, and he has separated plant pigments, and these pigments means colorful component, color producing components, right? That is present in the plant pigments. So they have separated as a color bands, different colored bands, so that bands have been taken as individual components from mixtures. So from that only column chromatography has been developed. So the first scientist who developed column chromatography was Michael Sweat in 1903. About definition of column chromatography, in chemistry, it is used to isolate a single chemical component from a mixture. Okay, a single chemical component isolation. I told column chromatography is applicable for isolation. And one more technique in planar chromatography is also applicable for isolation. What is the technique? Preparative thin layer chromatography. That is not that much sensitive and highly purification method comparing to column chromatography, where column chromatography is highly specific and high purification and isolation is achieved by column chromatography only, comparing PTMC. Okay, but it is most time consuming process for isolation. Mainly column chromatography is used to isolate a single chemical compound from a mixture. Okay, and this chromatography is able to separate substances based on differential adsorption of compounds to the adsorbent. Hope you know what is adsorbent and adsorption. Adsorbent here represents stationary phase. Adsorption is a phenomenon takes place at the surface of adsorbent. Compounds move through column at different rates, allowing them to be separated into fractions. So this isolated compounds will be considered as fractions. Okay. Then principles and theories. Principles of column chromatography. There are 5 principles coming under column chromatography: adsorption, partition, ion exchange, gel filtration, and size exclusion. As per your syllabus, you will be learning about adsorption chromatography, adsorption column, partition column, ion exchange column, gel filtration, and size exclusion column chromatographies. So these are all the principles we will be learning. Okay, and what are the theories behind column chromatography? There are 2 theories in column chromatography. We'll be following adsorption theories and partition theories, where adsorption theories are linear or Henry's adsorption isotherm, Freundlich adsorption isotherm, then non-linear or Langmuir adsorption isotherm, and bed theory. Bed theory is nothing but Brunner, Emmett, and Teller theory. Partition theories are adsorption theories follows adsorption principle. It says about adsorption principle. Partition theories will say about partition coefficient principle. And these theories are called as column efficiency parameters. So what are the parameters under partition theory we are going to see is partition coefficient, retention time, retention volume, capacity factor, selectivity factor, band broadening theories, and that is plate theory and rate theory, then resolution. Okay, these are all the partition theories we are going to discuss. About adsorption theories, there are four adsorption theories I told. First three will be applicable for solid liquid adsorption, where bed theory is applicable for gas solid adsorption. Okay. Another adsorption theories are for means apart from gaseous techniques, other techniques adsorption theories will be followed, where bed theory is meant for gaseous molecules adsorption, others will be for solid molecules adsorption. So now we'll see the first three theories: linear or Henry's theory, Langmuir theory, and Freundlich theory. Observe the linear theory. It is directly proportional to the concentration of dissolved concentration of adsorbate, that is C. Here C represents dissolved concentration of adsorbate or concentration of solute in mobile phase. We'll be having two phases in column chromatography, like stationary and mobile phase. Concentration of solute in mobile phase is mentioned with C, and concentration of solute in stationary phase is mentioned with Q, and K is equilibrium constant in these equations. So accordingly, taking in the y-axis adsorption density as Q, and in the x-axis dissolved concentration of adsorbate C, the graph is drawn. Okay, it is a linear theorem, that is Henry's adsorption isotherm. This is Freundlich adsorption isotherm. This is Langmuir or non-linear adsorption isotherm. So this will be totally non-linear adsorption. This represents linear adsorption. So where concentration is directly proportional to concentration of solute in mobile phase. In Langmuir, it is not equal. Concentration in stationary phase and mobile phase is not equal. Likewise, Freundlich, it will be medium comparing to Langmuir and linear adsorption isotherm. Okay. So these are the three adsorption isotherms. See the equations and learn. Okay. And this is bed theory for gaseous molecules. Bed theory for gaseous molecules. This says about vapor pressure of the gas molecules. Here, see, this is the adsorbent. Here are the gas molecules getting adsorbed onto the that is surface. Adsorption takes place by the gaseous molecules, and the adsorption takes place in the multi-layer form. So the theory is applicable for multi-layer adsorption of gaseous molecules, where in Langmuir model only one layer of adsorption takes place, where in bed model the different multiple layer of adsorption takes place. So the formula applied for multiple layer adsorption. And P0P all represents vapor pressure of the gas. And taking the graph, you can calculate vapor pressure and this values. Okay, concentration, velocity, this all can be calculated on what speed the molecules are getting adsorbed, and from the graph slope and intercept are calculated. Okay, this is bed model. You have to remember only this equation and what is the concept of bed theory. It is applicable for gaseous molecule adsorption. So in gas chromatography, this theory will be followed, whereas other theories will be followed for other column chromatographic techniques. Okay. And with this, I am completing today's class. In the next class, we will be seeing partition theories and other principles in brief, and even adsorption theory also in brief, and slowly we will be discussing in the next class. Today, now I have to go for meeting, so that I am stopping the class. Thank you all. If any doubt, we'll discuss in the class. Sorry for coming lately today and finishing soon. We'll discuss slowly in the next class. Thank you.
Thank you, ma'am.
Only 13 members. Kindly give your attendance. Many people, your attendance format is missing. I have written back. Kindly submit your attendance. Then only I can give attendance. Otherwise, you will be absent only. Okay. Okay. Thank you.
Thank you, ma'am.